Good morning, everyone. Welcome to the session on player experience. We will be having 5 papers coming from game analytics, user interfaces, user research. I'm Günter Wallner. I will be chairing that session, and our first speaker will be David Melhart. He is a PhD candidate at the University of Malta, and he will be presenting work on predicting player motivations from in-game data.
Yes. Thank you. And if everybody can hear me in the back as well, because we have limited amount of microphones. So, how much your gameplay reveals about your motivation? How would you even measure it? And is it even possible to create reliable player motivation models based your gameplay alone? Well, it turns out it's not just possible, your gameplay says it all. Hi, my name is David, and I'm here to tell you about a collaboration between the Institute of Digital Games of the University of Malta and Ubisoft Massive, in which for the very first time we model player motivation with a very high certainty just by looking at high-level gameplay analytics. So the game we chose for this experiment is The Division, which is a post-apocalyptic online shooter with a robust progression system in which players team up against each other or the environment, take on missions, level up their characters, acquire new skills and abilities. The Division provides a good and very robust testing ground because it facilitates many different approaches. It supports many different options and hopefully many different types of motivation. In contrast to many in-lab experiments, we get to work with real players and that generates real-life gameplay data. So our approach is quite simple. We measure motivation using something called the Ubisoft Perceived Experience Questionnaire and use supervised learning to train our models on high-level gameplay data. Our dataset consisted originally from 440 players, out of which around 300 remain after cleaning the data. Because we use preference learning through ordinal processing of the data, this gives us around 40 to 60,000 data points to work with. Why is that? More on that later. So the features we extract is 30 different gameplay features, which we generally can classify as general playtime. This means this describes how players spend their time in the game. Completion, which generally just means different types of missions. And progression, which is everything from player level to gear score to PvP progression. Then the player's early gameplay, and if they purchase the DLC and the DLC gameplay. Additionally to this, we also look at 4 big play styles, which are required through K-means clusterization. These are just very crude characterizations of different player tactics. Adventurer is the novice players, then we have the elites, the PvE all-rounders who try different sorts of aspects of the game, and the social dark zone players who prefer PvP action. The output of our models are labels through scores of different motivational factors. We measure these scores using the Ubisoft Perceived Experience Questionnaire, or UPEC. UPEC is based on the theory of self-determination, which is a popular framework in positive psychology to think about motivation. The core of the theory differentiates between extrinsic motivation, which is elicited through pressures and rewards, and intrinsic motivation, which is facilitated by 3 psychological needs. Although games do feature rewards and pressures, it is generally accepted that they facilitate intrinsic motivation more because they are very good at mediating the 3 psychological needs of competence, autonomy, and relatedness, which is a sense of accomplishment and mastery, a sense of control and self-efficacy, and a sense of belonging and connection to other players and NPCs alike. Additionally to these factors, the UPEC questionnaire also measures presence, which is a good mediator of both competence and autonomy. We arrive at the UPEC scores by taking these items and averaging them into 4 big scores. So with both the input and output in place, we just have to connect the two. We use supervised learning and preference learning specifically. We choose this approach because you can't really trust absolute values when it comes to subjective measures, but you can trust the relationship between them. So why is this? If you're interested in a detailed explanation, you can check out the paper on the screen now, The Ordinal Nature of Emotions. But in summary, this method sidesteps a lot of problems that comes with making assumptions about subjective data. So in our process, we generally just ignore the scores itself and just look at the preference relations. And for each pair of data points, we create 2 new data points. So in this example, data point A has an associated output of 4, and B has an output of 3. So we can say that A is preferred over B, and create 2 new data points, A minus B labeled 1, and B minus A labeled minus 1, which labels indicate the direction of the preference relation. We also apply a preference threshold, which is a hyperparameter with which we can control how much 2 data points have to differentiate to be considered significant enough to label the preference relation. It helps us reduce the noise in the data. In the experiments, we use the preference threshold of 0.1, which means around 10% difference between data points. So this problem can be solved with classification after this pairwise transformation. And this is why this method is super robust. We use rank SVMs as they are implemented in PyPLT, which is a Python toolbox for preference learning, designed and developed at the Institute of Digital Games. And you can read or hear it about soon, as in 2 weeks' time we are presenting the tool at the IEEE conference in Cambridge. But you can already find the preprint of the paper. Or you can try it after the presentation by visiting the plt.instituteofdigitalgames.com. So we created linear and nonlinear models for each factor and each factor of motivation, which is competence, autonomy, relatedness, and presence, and each gameplay modality, so play styles, gameplay features, and both combined. And validated our models using tenfold cross-validation. And non-linear models use a radial basis function kernel, which emphasizes the local proximity of data points. So, but how do our models actually fare? Well, at first glance, not that good. The average of the models based on only play styles alone, so only the 4 play styles, Adventure, Elite, PvE, and PvP players, give us an average of 57%, and the best models go up to around 70%. However, when we looked at the gameplay features, we observed a huge jump in the performance of the models. So here the nonlinear models go up to around 79% accuracy, with the best models reaching as high as 94%. All features combined give us some marginal improvements, but not very much. So we do recommend using gameplay data and not waste time on deriving player profiles, at least not in the crude manner we did it. And in this configuration, we got around 80% accuracy, with the best models for competence and autonomy maxing out at 94, and relatedness and presence at 92% accuracy. So as a last step in our study, we validate our predictions by looking at the gameplay of the highest and lowest scoring players in terms of predicted motivation. And we can observe patterns that echo the underlying theory of self-determination. So, for example, in competence, higher ranking players have a longer playtime and a steady progression rate, in contrast to low ranking players who just rush through early content. In terms of autonomy, a high completion and progression rate, and early success in PvP, and a long DLC playtime were good predictors, while perhaps unsurprisingly in relatedness, social interaction, both pro-social, meaning time spent in groups, and antagonistic, meaning killing other players in PvP, was a good predictor. We couldn't observe any play patterns in terms of presence, but our models were able to distinguish between players with 80% average and 92% maximum accuracy. So the two big limitations we run into during running these studies. The first is the processing of the Likert scales as average values, because Likert scales meant to represent ordinal values. By averaging the scores, we make a lot of assumptions about the distribution of these answers that probably introduce new biases into our models. So in the future, we would like to research ways to preserve the ordinal nature of these measurements, and perhaps by looking at the ordinal shifts within participants as a metric to analyze Likert scores. Another problem we had, or not problem, but limitation, is the focus on high-level gameplay data, because it's quite limited. So for one data point, we had descriptors of the whole lifetime of the player. So in the future, we'd like to focus on session level and even more granular data to model the temporal dynamics of motivation. And outside of these two limitations and future work possibilities, we'd also like to push for a more general understanding of both player motivation and player emotion, not just in a per game basis, but arching over different games. So research is also represented in the short video competition. You can watch our submission on YouTube. And we are the first entry on the ballot. And please don't forget to vote.
Experiment shows that it is possible to use high-level gameplay metrics and survey-based annotation to model complex emotional and cognitive states. Your gameplay really does say it all.
Thank you for your time.
So thanks, David. Are there any questions for David? We have plenty of time.
Well, thanks for the talk. It's also a really, really nice paper. So I was just wondering, how did you choose K for your clustering? Did you control if it actually counts for enough variance?
No, we actually had no control over it. That was all done by Ubisoft. So our collaboration was like they collect the data and we just get the data set. Okay. And the data set already had these clusters. Okay. But we were told it was very experimental. So it was like they just plugged in some stuff and observed something and we just got it with the data set.
Cool. Okay. I'm just thinking if the player type classification is good, it might also just not be a good predictor, right?
Yeah, probably. I mean, yeah, definitely.
I think they had a question over there. Over there?
Same question as
well, it's the same answer.
At least that's stable.
So I guess since you were given the clusters by Ubisoft, you had to go with K equals 4. But if you had to create your own clusters, what clusters would you believe that are suited for a lot of this?
That's a good question.
It seems like your fourth cluster on like 3 slides back, it wasn't really representative of any player.
Yes. Well, I think, for example, like 2 clusters would be better because the most dominant clusters were the novice players and the elite players, or one could reason that PvE players and PvP players, but then the computer can decide, of course. But I don't know. We do mostly predictive modeling, so we generally don't use this type of clusters. So, but I think it's hard to tell. It's more like I always think of K for cross-validation, K as a hyperparameter. So it's just we tune it until it looks like something.
So do these assignments to clusters change over time? Because I think like some of these player types you bring up seem like, you know, stuff that is set in a character or in a person, while being a novice or an expert, you know, switches over time and then like a transition region or something.
Yeah, no, because we only had like the high-level gameplay data. Okay. So, but we had the same issue, so that's why we were like a bit disappointed with the high-level data. We wanted to look into the granular shifts and tempo dynamics, but this is what we had for this study. Yes?
Have you checked how well the SAT results predict player enjoyment of your schools?
We didn't have any data on player enjoyment, so...
I guess that might be one of the ultimate goals of this assessment. Why would I be interested in the individual scores on the SAT question?
I mean, based on the theory of self-determination, one could like argue that if players intrinsically motivated to continue playing the game, they're enjoying it.
That's a theory, right?
Mm-hmm. It is a theory. It is a theory. Yes. Yeah.
Well, I think just saying I feel like SAT in games just needs a little bit of validation from my point of view. So it would be nice to get, you know, to use this data to actually get some better ideas of how well it actually serves as predictor of enjoyment, for instance.
No, I agree. I generally don't like to take anything granted either, but yeah.
Thank you for talking to Samir. You mentioned that you can't trust absolute values, but their relationship. Have you tried observing the relative difference rather than absolute difference?
What do you mean by relative difference?
For example, you said you were looking at A minus B, perhaps maybe A minus B divided by B, or just...
I see. No, not yet, but that's a good idea actually. What we had some experiments on is let a neural network figure out the actual metric between A and B, so just map them to each other. But and we had like good primary results, but nothing to report on yet. So.
Yes.
I have many questions, but I will give myself two. So, like, the first one is, did you validate it in any way the APQ, as in terminology, constructor materials? Because it's actually a questionnaire and...
Yeah, sorry, so the... so that's a published paper.
Okay.
Sorry, on the subject. We didn't do anything with it, but the researchers at Ubisoft validated it, and it's quite robust and valid.
And the other thing is connected to what Kristen said. Like, I think that according, it's a very good point, because according to some theorization of motivation, especially incentive salience and stuff like that, you can actually have a split between what is component of motivation that is related to frequency of behavior and actually pleasure related to activity. So I think it's actually a very good valuable point to investigate, because you can have players that produce a lot of playing behavior but not necessarily enjoying what they're doing.
Yeah, definitely, but so that's why we use self-determination theory, because here the intrinsic motivation is not really behavior related, because it has an internal locus. So there's behaviors or like activities that facilitate these type of needs, but it's not connected directly to the action you take. Mm-hmm. So because that's what they call an external locus, and then we call it an extrinsic motivation. And in the field we differentiate between a whole range of extrinsic motivation. So there's like this introjected motivation, for example, when you make yourself do something. So intrinsic motivation is a very specific type of experience.
I will introduce later.
Sorry, I need to cut the discussion. David is around, so if you have more questions.
Yeah, I'll give him a week.
Great. So let's thank our speaker again.
Sure, you won't mind. Not a problem. Please.
All right. So our next speaker is Carlos Pereira Santos. He's from the Pereira University of Applied Sciences and the Eindhoven Technical University. And he will present his work on how in-game questionnaires may or may not affect player experience.
Thank you.
Thank you.
Well, I had all that planned to say, but thank you until you just said it all. So, so I'm here representing some other co-authors, Niels and Vassilis-Javed and Panos Markopoulos from Dutch universities. And I'm here to talk about player experiences and how interruptions may be influencing it. To actually explain a bit about this, I have to go back into how this came about. So I was developing this platform, a data analytics platform, that allowed players to collect data from their games, but also allows researchers to embed questionnaires in games. Now, explaining this idea to some game companies, and I was talking about game programmers and game designers, and they were saying, oh, that's a good idea, but I don't want to use that, because it will influence the way the players experience my game. And I was trying to question about that. Like, yeah, sure, but there's already games, especially free-to-play games, they're already interrupting the player. They're using banner ads and pictures and images and videos and even mini games to do it. And there is actually services like Polefish and Zervata that actually do this already. They embed questionnaires into games. So, but they were coming back to me and saying, okay, but how much this is influencing the player experience? And I actually didn't have an answer for that. I scouted the internet, I scouted the literature, and I was trying to understand how much actually interruptions actually affect the player experience. And therefore, I had to come back and say, okay, if this does exist, this is a big problem, then I have to tackle this. Literature covers very much how much games influence the perception of the brands or the advertisement, but not the other way around. So I took an older game that I had called Runner. It was used for other purpose. And it's a simple puzzle platformer that you can double jump and grab the walls and be able to reach this green area. It's purposely done to a very raw, very simple, because we don't want to have any player attachment to the character or anything. And I basically created 3 variations for it. I created the first variation with no interruptions. The second variation, which it shows a video ad after he finishes a level and before the score. And the third, I introduced a research question, like a small, larger scale, multiple choice questionnaire. So the conditions were more or less like this. So it was just 3 levels. The player comes in and he plays level 1, level 2, level 3 in condition 1. And in condition 2, they had level 1, level 2. Then at the end of level 2 and before the score screen, they showed a video ad. And then they played level 3, and then the second video ad, different one. And afterward, they get questionnaires. Quiz, the third condition is the same as condition 2, but instead of the video ad, they have a demographic questionnaire based on the UK, the national survey they do every year about internet usage. And this is the results I got. So I after this, the players fill in the GEQ, the Games Experience Questionnaire, which covers a set of variables, and this is the results I get. I did an ANOVA analysis, and this is all the results, but I prefer to do a visual plot to graphics, because I think it's easier to view and explain. So I'm going to please start from this side to this side very briefly and try to explain the results I got. So all the shadowed ones are the significant results I got. The positive and negative effects is showed as expected, meaning that the control variable in blue had a much better positive experience and less negative experience, while the ads and the advertisements had a bigger experience. Those are significant. One thing that you're going to be noticing here is that the ads are actually having a more disruptive effect than the research questionnaire, the demographic questionnaire that they had. The games was perceived, the challenge of the game was perceived as normal, as neutral for all the three variations. Similar here to the previous ones, tension and noise was registered less for the control sample than the variation for ads and the questionnaires. Flow was something that was highly contested by the game designers, though, that this will interrupt data flow. We actually didn't register any significant data. So although there is some decrease here, especially for the ads, that seems that the average, the mean is lower. Actually, the ANOVA didn't register this as significant enough. So that was a surprising result for us to start with. On the other hand, immersion suffered quite a bit. So it was a significant result where control ads was registered much higher immersion than the other two. Another big interesting result that we got was competence. The player's perception of their competence on the game was registered much higher on the control sample than the other two. Although the challenge side, they feel the same. So they feel that the game is enough, it's normal in terms of all variations, has the same challenge, but the competence, they feel that they are competent on the game. It was actually much higher on the immersion, on the control sample. We looked back into the data and checked the scores, if there's actually variance, and there's maybe for some reason that the players were more competent in the control sample, but they were not. They were all the same. We think that because the interruption was done immediately after the game or the player finishes the level, and then the ad or the questionnaire was provided, they would actually have time to reflect how well they did on the game. And that actually provided this idea that, hey, maybe I was less competent. We also, the GAQ also has a post-game questionnaire. We also registered one significant result there, which is positive experience. Again, we have the same idea that the control sample registered higher than the other two. They had a better experience overall in the game. The other two was not significant. We also did perceived intrusiveness evaluation. This is a test that's done mainly for marketing purposes, and basically just has a simple question saying when the ad was shown, I thought it was, and there's a Likert scale questionnaire about how distracting, disturbing, forced, intrusive, etc. they have, and then you aggregate those results to get what we call the perceived intrusiveness. You can know more about this. This is mainly for advertisement purposes, so it's not for research. Never being used in research, as far as I know, but because it's a very simple question, I just replaced the ad by the research questionnaire, and I used those values to compare with the t-test, the ads and demographics. It didn't make sense to do the control variant because there was no interruption. Again, the results were rather interesting, very significant, as you can see, with a large T, and you can see there's a big difference between the ads and demographic questionnaire. Again, confirming that video ads of the 30 seconds was actually more disruptive than actually the demographic questionnaire. Something that I originally didn't predict, because I thought, well, the questionnaire, you're actually going to ask the person to read what's there. You're actually going to ask people to think about it. There are some privacy issues sometimes attached to it. So I think they will find it more disruptive, but actually it wasn't. So it was very interesting to see this result being shown. Because we use a national, UK national survey, we actually could compare those two samples. They are two different target groups, so it's not really directly compared, we can look at that. We actually contacted the UK national results. We got exactly the questions that they asked on the national survey, and we embed those into the game. They were very lengthy, but we thought, well, this is what they asked, this is what we're going to put in, and this is what results we got. And there is really big differences between the results we got from the national survey, which is this yellow dashed bar, versus the ones we got from the in-game questionnaire. Especially on the first question, there's big differences. We got that 85% of people already bought physical goods online, where the national survey is 0.27. Because there's two different target groups, although both from UK, so the participants we got was 236 in total, about 70 per each variation of the game. So this is results about 70 players. They're still rather, they're very different from the national survey. What we can say is that there is still an ordering effect, meaning that the order of the values that we got from the game and the national survey actually is the same. If it was completely random, if they would pick randomly the choice they would get, they would not get this ordering effect. So it seemed that they are related somehow. But again, this was not the focus of the study. The focus of the study was on player experience. So I honestly suggest that this would be taking about how reliable are these questionnaires in game to a different research. On the second question we got, so on the third level after that we got the second question, the national results and the game values that we got are very, very close. And that's about it. That's what I have. I have some takeaways. Clearly, interruptions affected player experience. Just be careful, because maybe it's not what we expect. It's not the variables that you expect. We didn't register anything on data flow. We register a lot in competence, which I didn't expect initially. So that's something that we have to take care of. This is also, we registered that video ads that are much more higher impacted, much more disruptive than research questionnaires, which was something that for us surprised a bit. But it's actually interesting to see. So all in all, I think this is a really good start, but more work needs to be done in this field. This was video ads versus research questionnaires. There's still other things like, what about a specific player experience questionnaire? What about pictures and images for banner ads or specific other things like that? And what about minigames? There's all these variations to be done there. And on top of this, I would like to do a more focus study on the reliability of the questionnaires, because a lot of these people probably just click and dismiss it, but initial studies that we got seems to have some actually reliable results in terms of the national UK survey. So that's basically about it. I'm open to questions. Thank you.
Any questions?
Hey, great.
Yeah, so you note a couple of things like video ads are more disruptive than research questionnaires.
In this specific setting.
Yeah, in this specific setting. But usually what you then would add is, we suspect it is because of. Because that would give you some idea of maybe what would happen to minigames, etc. So do you have any possible explanations?
We do. We think that because the video ads starts immediately, and I showed it a bit on the video I showed there. It's starting about the game. It's really shocking, and we used at the time a video ad that was actually. Sorry, I was just play it, please. Come on. So the video ad we showed here, it was a video ad that actually was running at the time on multiplayer games or games online, and it's really. The way they start the video is really disruptive. It has this big explosion to start with, like this. So I imagine that was a bit shocking, but that's actually what is actually we're trying to replicate exactly what's happening in this type of games. This is exactly what happens. So there's a 30-second video that they cannot do anything until it finishes, and then you have a dismiss button. And it's maybe a bit annoying and a bit disruptive. So, and I imagine this is where the people start thinking on other things. And that's what we imagine that the game flow would be affected, because they're starting moving out from the context of the game and completely ignoring the mobile phone or the web browser or whatever platform they were saying. While this one, which is the questionnaire we get, it's slightly more different. They are passed from one task to another, and after finish that task, they move to another one. That's what I feel that happened, although when I imagined it in the beginning, I imagined that it was going to be something like, oh, they're asking me personal questions. They're asking about my personal behavior online. Why do they want to do this? Okay, this is something that I imagined it was going to be the reaction, and it was trying to intriguing to understand what happened. But the players, it seemed to just accept it and just click it away, and they'll read it and use whatever was there. So this is what I think. But I would like to do another research on top of this where I actually ask the players what's happening, because it was a completely quantitative study. I didn't ask any post questions to the players.
One here.
So, about the setting of the game, was this like something that players expect to see an add-on, or is it like a premium type of game?
No, it's a free-to-play game that was online. It was not even in a mobile setting. The participants were recruited to play a game. And we didn't say anything about if it's going to be a game with interruptions or not. It was just playing here's a game, play it, please. Okay, and that was the setting. So we didn't say anything about the game has interruptions, no interruption. There was nothing about it.
Have you done any experiment around when to show the ads? Because like from what I know, like the
yes.
timing is very
yes, and I think that's what affected the data flow or the game flow aspect. It was at the end of the level, then it shows the ad. So it was what we called timed or interruption. So it was a good place to do an interruption, and the players were expecting that was going to be transitions of somehow because they just finished the level. When they failed the level, we didn't show any ads, so there was no interruption there. So I imagine, yes, the timing of interruption is very important. If we have data on that, no. So the theory says that, but we didn't do any study on that.
Thank you for your presentation. I have two observations that I would like to know your opinion about. The first one is from memory when you use GEQ, the competence, I think the competence dimension, some items are related to how quick you reach your goal. And if you're actually providing something that prevents the player to reach this goal, I will expect them to write these items before. The second one is about the context of the interruption. So usually, some games that actually provide some ads, they do this at the time that the player accepts that it makes sense. So for instance, I failed something, then I have to watch the ad. It's my punishment, let's say. In this case, it's like you finished your level, as a reward, you provide them with an ad. So maybe this can also have an impact on how they perceive the interruption.
For the first one, related to competence, I suspected something like that as well. So that's why we looked back into the data in terms of the scoring, if the number of tries. So we actually had three measurements that we looked at in terms of the player score, let's put this, or the dynamics. It was basically the number of attempts they did the levels, how many times they failed, the total time and how much time they took to reach the goal successfully, and how much time they actually completely to do the complete level. So including all the attempts, how much time they took to complete that level. And we didn't notice any difference between the three compositions. So I don't feel that it's because they were interrupted to move to the score level. I don't think that's exactly what happened there. It's mainly because they reflected. That's what we felt that this was happening. Related to your second comment on, sorry, can you remind me again?
It's about if when you introduce this, it's felt like a punishment.
Yeah. About the felt of the punishment. Again, we try to mimic existing games. And normally that's not the case. Actually, we tried multiple samples of different types of games, and there was actually interruptions in the middle of the game. So where you're playing someplace, just the game stops and freezes, and there's a big video ad for 30 seconds, you cannot move onwards. And it was timed, most of the games showed it at time based, And I didn't felt that it was during punishment. It was mainly because you want to buy something or here's some coins that you want to go for. So it was actively on when players were doing other activities than just playing a regular game. So I tried to mimic that in the same setting here. I felt that when you lost and you have to show a video, I thought that was a bit too disruptive, and the game was actually shorter. So it's about 5 minutes or 10 minutes of play. So I didn't imagine that if doing on every time that you lost a level or every 3 times you lost a level, give me enough consistency in terms of having all the players experience the same setting.
I'm sorry, maybe we can infer that due to the break.
I'm available here until 3 days. Oh, sorry, I had this running.
He's here, and it's good to see. So many questions.
Yeah, good. I'm really passionate about this, so if you want to know more, please come here.
So we have a few more speakers coming up.
Yeah, but I'm not sure. I used some graphics like this one. That should be mentioned these from actually, so I'm not actually sure if this is correct or not.
Oh, I don't know about that. I think there is a worry that some of the image might be.
Yes, maybe I won't record, but I won't beware too much, probably.
Okay.
Yeah, I just another.
Okay.
I just don't work at something.
You know, you could still have the copyright notice somewhere on the slide.
Okay, so next speaker is Felix. He's a PhD candidate at the University of Duisburg-Essen, and he will be presenting work on VR settings. So have a go.
Perfect. Thank you. Yeah, welcome all. And I'm the one on the left side, and I would like to present you our results of our study, which investigated the role of physical co-presence in multiplayer room-scale VR. To start this, if we think of a multiplayer VR setting, we think of persons being physically apart, are playing together in the same virtual space. So, in general, modern VR technology enables people in professional as well as in entertainment domains to interact simultaneously in those worlds, even if they are physically apart. And though they might be physically apart, the virtual world suggests that they are in the same world, in the same virtual world. And normally, such a scenario is that we have one person playing in his or her own physical space, and we connect to other persons playing in their own spaces. And in the virtual world, it seems like we are playing in the same virtual world. But if we reconsider this idea and think about, okay, what about if we have a co-located multiplayer VR setting, where we have one shared physical space, and everyone is playing in the same physical space. It's much like a modern version of a couch multiplayer, but in VR, in multiplayer room-scale VR. And if we want to compare those two settings and see whether one of these settings is beneficial for the player experience or for the game performance of the players, we need to take a step back and look at the benefits of co-located play for regular non-VR games. And there are some papers indicating that when you play games in a co-located setting, the player experience may be higher in the co-located setting, or rather, several constructs which are related to player experience are higher. And this is kind of interesting since both players focus on the same screen in the remote and in the co-located setting, but because they want to play the game and they don't focus on the other players, so why is the player experience higher in the co-located setting? And what is more interesting for us is whether this effect can be observed for multiplayer co-located VR. And if we try to answer this question, what we wanted to do in our paper, you have to differentiate between two systems. On the one hand, you have the cardboard system, which is more of a static VR approach, more of a seated VR, where you can't walk around, you sit and you enjoy the VR experience, though you can move around, though you can turn around, sorry. And the first results of the study indicate that cardboard VR can equalize the effects, whether you play co-located or remote, it doesn't matter. Since you have a cardboard which fades out the environment or the real environment, this is not really surprising and in line with thinkable argumentation. But if you take a look at more complex systems, if you think about room scale systems such as the HTC Vive or the Oculus Rift, sorry, things get a little bit more complicated. And this is because if you share the same physical space with another person, you might bump into this person when you play there because you can't see him and or can't see her. And this might be a little bit difficult. Also, you don't want to get into the personal space of the other person. This is why you tend not to go near the other person. And first results indicate that playing in the same physical space on a multiplayer game, let's play not focus on their actual task and neglect the task, and rather focus on the collision avoidance and the other player. However, this was done in a simple navigation task, and we thought, what about if we transfer this idea to a complex cooperative multiplayer setting and see how a co-located setting will affect the gameplay. And for this, we developed a simple testbed game. And in this game, you are playing a wizard standing on top of this tower. And your task is to defend incoming monsters, which try to steal books that are hidden beneath the library. And yeah, this is pretty much the story. And once the monsters reach the tower, they steal the books and they try to get to a certain random point to the forest. And once they reach the forest, the books and the monsters are lost forever. But you can stop them, you can shoot at the monsters. So both players are located on top of the tower. They are represented with this beautiful head and the magic wand. We used the HTC Vive, so the wand is controlled by the remote of the controller. And the dimensions of the tower are equal to the dimensions of the real tracking space. Also, the position of the players is equal to the position, so you know where the other player is. You have the possibility to shoot at the monsters using the trigger. I will show a quick demo after the slide. And since it's a cooperative game, at the one hand, both have the same goal, but you also have to develop a fashioned strategy to kill the monsters because you can't focus at the same spot, you also have to divide the attention. We further implemented two cooperative mechanisms. The first mechanism is the consecutive shot, so if one player shoots at the monster and the other player shoots at the same monster within the next 3 seconds, the shot is 5 times more powerful. And the other cooperative mechanism is a cloud, which requires the attention of both players. So the first player can activate the cloud machine, which instantiates a cloud. The second player then can navigate the cloud to a desired point, and the first player again can shoot at the cloud, which leads to a huge explosion, killing all monsters in a certain radius. And here we have the setting of our shared room. And I hope it polarizes. Perfect. Okay, here you can see both players in the co-located setting, standing on top of the tower. If we jump into the gameplay, and you can see one player creating the cloud, the other player pointing the cloud at a certain point, and the first shooting at the evil monster who is instantly killed. Among the players try to defend the monsters, and they are focusing on different points, and now they are focusing the same point, and you can see the consecutive shot come into action. Yeah, perfect. Okay, this is the shared space condition, and then this is a co-located condition, and in the remote space condition, we had something like this, where the dimensions of the first room were taped to the second floor, so we had the same dimension in every room. And we used the game engine Unity to develop the game, and we used Photon for the network. So regardless of the game was played in the remote or in the co-located condition, the network, the game information was synced by the network using Photon. And to analyze how the player experience and how the performance in the game was, we did an evaluation. We did an evaluation using a non-repeated measure between subject design, which means that we had two conditions, a remote space and a co-located space condition, and every group only did one of those conditions, either the remote space or the co-located space condition. We had several psychological as well as objective measures to get insights about the performance, player experience, and the cooperation. We had some validated questionnaires. I will just list them up. The first one is one of the most interesting ones, since it's a cooperative social presence subscale, and it measures cooperative social presence. And since cooperation was a key factor for success in this game, this is one of the most interesting questionnaires here. We also tried to assess the quality of communication between the players and the collision avoidance behavior. For this, we used self-formulated items and no validated questionnaires. For the objective measures, we on the one hand used the quantity of communication. This was done by both players communicated via Discord while playing the game, and recorded the whole audio stream all the time. Then count out all the information with the volume which was below a certain threshold, and the resulting audio file was our quantity of communication. We have the number of cooperative interactions, which is the consecutive shots in the thunderstorms clouds created. And we had some performance indicators, which are monster skills and bookstone. The evaluation was pretty simple. We had a start, we had some questionnaires before the actual gameplay. Then the participants had a short tutorial learning about the game and about the cooperative interactions, and then we had 9 minutes of playtime, regardless of which condition you were in, and regardless whether you are good or bad, so you could not fail at this game. It was 9 minutes in total, regardless of how you performed, and the game got more difficult with every wave that was coming in. Afterwards, we had some questionnaires, and then the evaluation ended. In total, it was about 45 to 60 minutes. So, and we had 92 participants. We needed to exclude 4 due to technical difficulties in those particular cases. We had a really low VR experience with 70% of the participants reporting not to have more than 2 VR experience in total. And just to mention it, we had really low SSQ values, surprisingly low, so this should not be factor when interpreting the results. Okay, so let's jump to the results. The first one, I would like to focus on, I hope you can read this, is the IPQ, the Cooperative Social Presence Gaming Questionnaire, and the Collision Focus. Though we find no differences for the IPQ, we found significant differences calculating ANOVAs for the CCPIG as well as for our subscales, and I have this here on Utah. Indicating that the cooperative social presence is higher in the remote space condition in contrast to the co-located space condition. So it is, in contrast to the results you can find when you look at non-VR couch multiplayer. This is kind of surprising, since one of our theories was that this is because of the collision focus, because players tend to focus at the other players, tend to not bump into the other player, and thus not focusing on the game and thus the cooperation. However, our collision focus did not show any significant differences between the groups. Another result we found was in the qualitative communication. So people in the remote space condition tend to report a higher qualitative communication score in contrast to the co-located condition. And for the quantitative communication, we found no significant differences. The same tendency is also observable for the performance. We found that in the remote space condition, the players tend to have a higher amount of killed monsters than in the co-located space condition. However, we have found no differences for the number of blocks stolen and no differences for the number of cooperative interactions, which is also kind of surprising because the cooperative interactions was a key factor of killing several amount of monsters. Something which we found, which is also worth mentioning, is a co-founding variable, because we have checked for the player familiarity, since this is a good moderator for the cooperation and the performance. And we found a high correlation between the familiarity of the players and several constructs. Among those are several constructs which we found a significant difference for. So we calculated multiple analysis of covariances to detect differences between the game settings while controlling for player familiarity as a covariant. The results of the multiple analysis of covariance show no deviations from over, and thus indicating that though we found correlations between the player familiarity did not impact our findings. Okay, so what we can say, or what we might say, is that physical separation can have an impact on players in multi-user VR. We found a significant difference in the collaborative social presence, which is since we have a collaborative game, it is an important construct and shows that the collaboration between those players was not perceived as good as in the remote space condition. This also explains why the performance or some performance indicators and some communication indicators are low in the remote space, in the collocated space condition. And it seems like playing in a co-located setting seems to shift the focus from the task, from the game. But we really don't know why, because our first idea was this is because of the collision avoidance, because I don't want to bump into the other player. Our results show that there's no difference in the collision avoidance between the two conditions, so we have to take a deeper look of why. Another explanation could be because of the use of wire HMDs. If you play alone, you can estimate where your wire is. If you play with another person who's also having a wired HMD, you maybe the wires could get tangled up, and you are really don't want to bump into the other player's cable. So what we would like to do, of course, is using wireless technology. This is, I think, pretty obvious. On the other hand, we want to use validated methods to analyze the quality of communication. Right now, we use self-formulated items, which is a great first approach, but it's not validated. And what we could do, we have all the recorded audio file. We could do a deeper analysis of what the players were saying. And this would take like a really, really long time, but would get a better and deeper understanding of how the quality of communication was and why it differed between the two conditions. And what we also should do is track behavioral data to get a better insight into the player's movement and see whether collision avoidance was a thing and might be an unconscious process, and the data shows that people try not to collide with the other player in the same room. This is something we should look into to have an explanation of why we found our results. Okay. Thank you for your attention.
Thank you.
So, I played a VR game in which I had to basically be co-located with another player, and it was a following VR game. And I have to say, basically, avoiding your partner is one of the most distracting things in one of those VR games. But one of the things that this person that I was playing, who was a developer, that was playing around with the idea of having a game feature that would tell you whether or not you were getting too close to your partner. And I was wondering, have you considered if games integrated a feature that tells you, hey, you're getting too close to your partner, you might want to back up?
Yes.
Face position.
Yes, this is actually one of our current works. The main focus on this work on the next work is try not to get into the personal space. So you can configure your personal space, which is not more focusing on collision avoidance, but rather not to get into the physical or the personal space of the other player. But I think it would solve both problems at once. Yeah.
Quest, because right now the Oculus Quest allows you to delimit your space. And actually, we try with the people and we feel much more secure, because as soon as they go just a little beyond or nearby the space you design, then a grid comes up, and then they feel, and they start with the camera. The camera starts. IR camera starts.
This is a really good idea. So the Oculus Quest, I think it's not long enough on the market. Like it's like, yeah. So we have Oculus Quest right now, but we have to port the game, and this is something we definitely could look into.
Because it made a lot of difference in our experiments with educational games.
Okay.
Because actually, as soon as first of all, you decide your bounds. And then, as soon as you just come nearby the bounds, the AR camera turns on, and then basically you see outside. So you feel much more actually relaxed in this.
Okay,
with the experiment with Oculus Quest in the past, it is a big difference in terms of jump, in terms of usability as well. So it will play better, it will move better. So I recommend.
Okay, thank you.
One last question. Co-located play itself is always difficult. So how long did the training session for those people take? Because if you play, for example, squash together, it's really hard to initially get used to the other person moving in the same physical space. And once you basically reach the training that you understand the other person's movement, then everything changes totally differently. That could affect you massively as well.
Yeah, this is a good point. I think the training was pretty much our tutorial that the persons had on the evaluation. I'm not sure how long it took. I would say about 3 to 5 minutes. It was pretty short.
Did you see any difference then with people through the session, that they basically got accustomed to the other person in the space more, or was it the entire study short?
Unfortunately, we have not tracked how the experience evolved through the experiment, but this is a really good idea. I think we should keep up. This is especially if we track the behavioral data, we could get a better insight about the evaluation, about the evolvement of the collision avoidance, or how the player interact with each other. Yeah, thank you.
Okay, so let's thank Felix again. And our next speaker is still Felix, still PhD candidate, and still at the University of Wisconsin. And representing work on sentiment analysis and speech. And I think that also connects somehow to the previous work.
Okay, yeah. So, welcome back. This is the second paper I'm presenting, and the first author of this paper is Philipp, who's a good friend and colleague of mine. Unfortunately, he could not be here today, so he asked me to do his talk, which I did, or which I will do. And there might be some questions I can't answer. I apologize in advance. But if I can't answer the question, feel free to write as many mails as possible to Philipp. I'm really happy about this. Also, this is a short paper. This was published as work in progress, and you will see why during the presentation. Yes, so if you remember my last talk, there was this one problem that we had a lot of communication, and we did not analyze the data because it was just too much. It would take hours and hours and hours, and so we said, okay, how cool would it be if you could see where players were saying something during the game without jumping through hours of video material to analyze it manually, especially if you consider you have a first study and you have first results. And then you take a lot of hours, take hours and hours to analyze it just to get the result that you can't use your data, that everything the person said is unusable. And this is really bad. So our idea was, okay, we want to make it automatically, and we want to analyze speech in games to have a better understanding of what the player were experiencing. And so to summarize our goals, on the first, we think that player speech in a game is a valuable perspective on player experience, especially if you communicate with the other player, and I'm pretty sure you all have experienced that when you play the game with another person, or even alone, your speech was reflecting your emotional state. especially if you are toxic in a game, this is a great information resource. And what we could also do, and what was also a goal, is that we want to assess the emotional valence in our case of German communication during the gameplay, to get a better understanding whether the things the person said during the gameplay is positive, negative, or neutral, just to get a better understanding of maybe how the game works. And the next thing we wanted to achieve is that everything we developed is modular, to have an automated process, and also to allow to change certain modules, whether we want to implement it into another engine, or we want to have another visualization, or another another emotional valence program. So imagine you have a game like this. Imagine you have this mysterious looking island which you have to discover, you have to go around, you have to find different chests, you have to find secrets, and the game developer is pretty interested in how you get through this island and how you are able to, or what are you saying while you discover this island. And imagine that this would lead to something like this. I will explain this in detail after I explain the pipeline. This is just a short overview. So imagine you have an overview over your island, over your game area, and you see the moving path, and you see where the player said something and how the speech was classified, whether it's neutral, this would be gray, whether it is negative, it's red, or whether it's positive, it's green. And this could give a great first insight, for example, if you try to see how the player is doing at the first minute of the game, or in the middle of the game, at the end of the game, and where he is confident and where he's not confident. And the first thing I want to show you here is the pipeline, how we get to this before I describe this in detail. So keep in mind that everything here is modules, so we can change all the elements, and we have 3 different elements in our pipeline. We have data tracking, the sentiment analysis, and we have the data presentation. The data tracking, in this case, was implemented in Unity, and but it can also be implemented in any other game, in any other game engine. You just have to be careful with the interface. So here in Unity, you just have different classes storing the different game units. So we have data units, position units, and speech data units. For a particular case, storing game events like opening a chest, position data, okay, this is pretty obvious, and speech data units, which contain the language of the person and also the text. So we have our Windows dictation recognizer we use, which allows us to transfer the speech into text, and then we can store the text as well as the speech of the player for this certain element or for this certain action he did. All the information was stored in our Node.js server, so this served as our backend, and was stored in our database. We used Mongo database for this. So, and the next step is our sentiment analysis, and here we had 2 classifiers which automatically classified our speech data units either as negative, positive, or neutral. For this, we implemented 2 different approaches. On the one, we had a lexicon-based classifier. This was based on simply the content of the words and predefined valence of the words, and also of the structure of the sentence. Okay. And we had a long short-term memory neural network classifier, which we fed with 80,000 pre-labeled German Twitter posts, which also were classified as positive and negative and neutral. We used Python, Keras, and TensorFlow to do so, and the result was stored back in our database and enhanced the data we got from Unity. Keep in mind that this is the work in progress. So far, the neural network had the efficiency of 64%, which is not great, but it is definitely improvable, but it's just a work in progress, and yeah. So the last step is the data presentation. It's on the front end. We use React and TypeScript. and which allows us to present the data we stored in our server or database. And yeah, we can have different projects from different games. We can select the level, the sessions, and this will finally lead to this result, where you have a great overview of the map. And you can see the path the player took. And you can even filter the time passed, so you can see where the player was after 1 minute, 2 minutes, and so on. You can define the structure of the grid, so these grids can be more specified or more generalized. And then when you click on one grid, like for example you click on this area, you get detailed events on this side of the interface, showing what the person was saying at the time, and whether the classifier classified it as neutral, negative, or positive. You can edit those labels and say if the classification is wrong, or maybe the classifier, maybe it was irony or whatever, and you can replay what the person was saying during this particular event. And furthermore, you can filter the information and see that you only want to have neutrals or positives. Yes. And the question is, what's next? So, yes, use the pipeline in multi-user VR studies, because for the example I just showed you, one person playing a game and using speech as an information resource might not be that good, because when you play alone you don't talk as much. But if you're in a multiplayer setting, you talk a lot, and this could be a good source for information. Of course, we want to improve our sentiment classifier. Right now at 64%, it's better than random, but not that good. And we want to work more with game developers and see what they really need in their visualization to enhance and to supplement our current visualization. Okay, so because I have no time left, this is the conclusion. We had a proof of concept implementation, which demonstrates the potential of the approach. Keep in mind, this is work in progress, and we're still working on this. And or rather Philipp invites you to adapt the architecture and aspects of it, so all of the code and all of the framework will be online at our page. Right now it is online because we have discovered a major bug, and but it will be online there. And if you have any questions I can't answer, or have specific questions how you can use this for your projects, just write Philipp a mail, and he will answer you immediately at every point of the day. Okay, yeah, thank you, that's it, and I'm now open for questions.
I have two questions. Okay. First one is, which game, did you guys make your own game?
Yes.
Okay, yeah. So that was my quick question. The second one is, for the sentiment analysis of the text, have you guys considered using like NLTK or something that's a little bit like open source?
So this brings me to the part where I must refer to Philipp, because this was his part, and I have not considered it, but I'm not sure if he has.
You guys used text analysis. You looked into just using the pure sound and see if the voice and the pitch.
So far not. So far it's only based on the content of the language. But this is something which can be improved, yes. And this is a good idea. And actually I'm not sure if Philipp is working on it right now, but it could be.
My second point is, during your final step, on where you have the visual app, or web app, where you can actually see the sentence, etc., do you try to get information that where the game designer is looking at the data and correcting it, you feed that information back?
Yes.
Yes. So I didn't understand how do you get how do you transform the voice to speech. So do you guys have any voice recording of the game? Do you need to have a specific setup in your game?
So right now, yes, you need a voice. You need to record the voice.
Any recording?
Yes. So just any microphone will work.
Yes.
And so right now it's based on the Windows dictation API. Let me get back here. Yes, Windows dictation recognizer, which allows text-to-speach. It works with every microphone. Once it recognizes the Windows, in our particular case, you can store the audio file. And the audio is recorded at all time during the gameplay, and then is cut and put into certain, it's rather associated with certain game actions, certain elements which are stored in the event data units.
All right. So, okay, let's thank Felix again. And our last speaker.
It's not me.
It's not Felix. It will be Robert Ross from La Trobe University, and he will present how to turn classrooms into escape rooms to improve student engagement.
Absolutely. Yeah.
Thanks very much. Well, my students from Australia have been back in the classroom for about 3 or 4 weeks now, and this is the sort of thing that I don't want to see. Not really seeing it here. If I did, I'd expect it's jet lag. But we don't want to see that. We certainly don't want to see that, and we definitely don't want to see that, do we? Well, how do we engage students so they learn? There's lots of competition that students, that we have as academics at times, to engage students and make sure they're getting what they do, particularly for online or blended courses. Things like Facebook, YouTube, which in many ways are intrinsically more interesting than some of the things we're teaching. We certainly don't think so, but some of our students unfortunately do. And those traditional lectures and tutorials, they're highly dependent on how good the lecturer is at the time or what mood they're in, but also the mood of the students, and that's something that's a bit harder for us to actually control and change. Some students also don't understand why something's important until it's too late, until they actually needed it for something. And this is something I've found as well, that being in the workforce for a number of years, you're like, oh, I learned that in second year, what was it again? And you go back through the textbooks and find it, but they don't realise how important it was at that time. Now, this is something we've probably seen before, and we should take it with a grain of salt in terms of the actual percentages and things related here. They're highly dependent on how the person's feeling at the time and the skills of the presenter and things like that. But intuitively, we know that the active learning approaches, where we're actually doing something and being involved and having to have creative input to something, we tend to remember things better than if we had an approach where it's quite passive, where we're listening to someone talk or give a presentation or something like that, or just maybe reading a textbook. And so we want to head towards these active learning approaches, and particularly that last one there, which leads us to escape rooms. Who's done an escape room? Yeah, in a room like this, I probably should have asked who hasn't done an escape room, because I assume most people did. I was speaking at Bristol earlier in the week, and it was about 50-50. For those that haven't, worldwide game, starting about 2007, coming out of Japan, and basically it takes the concept of a puzzle hunt activity, which has been around for decades in places like MIT, and essentially fits all those puzzles into one room and compresses it in size and magnitude. And the general idea is you lock a bunch of people in the room, there's a bunch of puzzles they need to solve to escape from the room. We don't physically lock them in rooms, that's actually quite dangerous, and all sorts of health and safety fire hazards and things. And typically with a time limit of maybe 60 minutes or something. The commercial ones are typically like that. They're great for teamwork, problem solving, and companies take their staff along to these sort of things for a corporate retreat and get them working together and solving problems together. Well, how do we apply that to education then? Well, we don't have lots of little rooms that we can monitor what's going on in each of those little rooms and divvy up our students across maybe a course with a few hundred students in it. It's just a bit impractical. And so typically we'll have a big room, a whole bunch of tables separated out, and put each of the students on a table, a bit like what we've got over here. We need to give them some problems to solve. And my background's in robotics, electronics, digital electronics programming and things like that. And there's a whole bunch of problems in those sort of areas that you can have numerical answers for quite easily. Having said that, we've had problems across biochemistry, maths, a whole bunch of different disciplines. Basically, we want a numerical answer where there's only one solution. Two solutions starts getting a bit tricky. We put each of the puzzles in sealed envelopes, and you can see some of the envelopes on the table there that they're ripped open and gotten past. And we've been finding that groups of 3 to 5 students tend to work fairly well. We've run them with as low as 2 students, or we've run a few with 1 student. It kind of defeats the purpose of engaging with teamwork and things like that. but we haven't gone much beyond that because people just get left out and don't actually get to contribute very much. But we also need a way to validate answers and provide feedback. And some of the escape ed frameworks and things that are around there sell combination locks and things like that. But across a whole classroom scale, you don't want to keep the same passwords across successive escape rooms and things like that. It gets a bit difficult to do it. And so what we created is this guy. We call him an escape room decoder. I wrote escape room decoder there, mostly for the airport. And put it in my, not my carry-on luggage, but my checked-in luggage for obvious reasons, just in case. We've made it open source, so you can download all the files, 3D printed files for the actual box and things like that. I'll show you what's inside in a sec, but it's reconfigurable, so you can have any code you want, between 1 and 8 digits long. We've said to you there's 3 rounds, so round 1, round 2, round 3, envelope 1, envelope 2, envelope 3. We can assign penalties for wrong guesses, because when we ran this the first time with academics, we noticed there were some academics that were a bit out of the area, and so they spent most of their time trying to brute force attack the thing, and particularly if some of their colleagues had got the first 2 answers right, and there was only 1 or 2 digits left, they're like 1, 2, 3, 1, 1, 2, 3, 2, 1, 2, 3, 3, and try to get the last digit there. So we can assign penalties. We don't need to, but typically we assign a 1-minute penalty for our students. We'll talk in a bit about school engagement, because we do high school engagement. We typically don't assign penalties for that. We've also got clue delivery. So every 5 minutes, the thing reveals a new digit. We can turn that on or off. But basically, we don't want students get stuck and lose all hope in the world because they can't get past this one puzzle. So we give them a digit each time, and our puzzles are typically maybe 4 or 5 digits in length, and so it doesn't give too much away. If they're stuck for 15 minutes, which some of them have been, they'll get the first 3 digits. We never give them the last digit. That would just give the game away, literally. We also have a countdown timer to track the progress so they can see how long they've got to go. What's inside the box? It's a little Arduino microcontroller right in the middle there. We did that open source, really simple for the students, for people to build and recreate. We've got batteries, a keypad there, 3D printed case, the whole thing, and a key there, so once we start the timer they can't restart the timer. The whole thing costs about $30 or so to build, including 3D printing. One other thing that we do is we set a theme around it as well, because we want it to be a bit more immersive and fun. And so we've created a whole bunch of storylines that the students, they're currently text-based, we're looking at VR ones in future, but a whole bunch of storylines that they can actually read the storyline and immerses them around the problem. So we've got about half a dozen at the moment, but things like they're in a cave-in and there's an emergency exit way out, a Cold War bunker that they've been stuck in, which kind of works fairly well with the little box thing. We've got some droid-themed escape ones, which are a bit Star Wars-esque. And those storylines tend to be progressive and even sometimes reveal clues. So there'll be, as they open the next envelope, a bit more of a storyline and maybe some clues embedded in that which actually starts filtering out which students are actually reading the storyline and which ones aren't. Here's a few different puzzles that we've used over the time. I mentioned we've got some from biochemistry and things. I haven't put them here. But a bunch of them you see at the top there. We've got a whole bunch of different number bases, so binary, decimal, hex. You need to add them together. It gives you one of the clues. Some serial data coming off a USB or RS-232 line. They need to decode what number that corresponds to and punch it in the box. These ones are actually physical in nature, and so that one there, there's a whole lot of inputs connected to outputs. They use a multimeter and actually measure what's connected to what and punch, for example, if one's connected to 6, 1 6 into the box as the first 2 digits. This one gives different analog voltages, so 1 might give 3.5 volts, 2 might give 4.5 volts or something like that. These ones here, there's some logic gates that you need to fill in from this truth table to work out some sort of logic pattern given the number of inputs, what are the outputs going to be. And this final one, these 7-segment displays are great for escape room, embedding problems and things like that. We give them a circuit diagram and a whole lot of 1s and 0s that will translate into LEDs being turned on and off, and they need to work out what numbers the LEDs are actually displaying there. So a number of different types of puzzles there. We've done a fair bit of evaluation both with academics, with students in class, but we've also done it at an open day as well. Now, I'll talk about the open day and show the examples in a moment. one of the interesting things we did with academics, we set a really hard escape room for them. It was an electronics-based escape room, and only about half of our academics were from that area. The rest were from civil engineering and manufacturing. They were quite out of their depth. But we spread out the team so they had experts from electronics on each of the tables so they could help each other. This worked really well for every table except one. That one table, one academic felt really alienated and he didn't really engage very well. All the others engaged really, really well. And so we had focus groups afterwards with them, a week after, and the academics that weren't from that area still had significant retention of the key concepts in solving those problems a week later, which were areas that they'd never actually seen before, which was pretty good. Our student responses, they absolutely loved it. I got the best student feedback I've ever got as a result of running this in the classroom. They said it's great to get that confirmation of practical knowledge because they often fool themselves into thinking they know something. They're doing exam revision. Oh yeah, that question, what's the answer? Oh yeah, I know how to do that. Without actually challenging themselves to do it all the time. This challenges them to do it. So it shows them what they didn't know, and they were also keen, which was surprising, they were keen to have an assessed activity. When we got the responses from the academics, there were two things that they said. Students will not want any marks associated with this, and these problems are way too hard for students. When I told them that these were basically past exam questions, the second complaint fell away, and I said, well, let's see if students actually want marks associated with this. And during the first one, they unanimously said yes. During the second one, 80% of them said yes. The second one was significantly harder than the first one. Human nature coming out there. Well, Open Day. Open Day, we run Open Days every year where we have visitors and potential students coming to our university that we want to capture in some way and extract money out of and put education into. So it's a perfect escape room-esque environment. We don't want them to escape. These are the three puzzles that we're using with them. So this one here, it's basically a seesaw puzzle where basically where that axis point is and the weight that we put on there will affect what weight that they need to put up there at the end there. And so that was one of them. We gave them the basic formula for that, but no other information really. This one, it's been a popular puzzle on Facebook and things like that. Which cup will fill up first? And they need to trace it through and work out which of those cups or buckets will fill up first. And finally, a whole lot of number sequences. So there were several of each of these puzzles in each of the envelopes. So this one, we had Fibonacci ones as well, and all sorts of things like that. We had about 100 visitors through this one, and we had a follow-up survey asking them questions relating to engagement, and some of the classic questions of, did you lose awareness of your environment, did you lose awareness of time, and things like that. We only did this 2 weeks or a week and a half ago, but the results were skewed very highly to, yes, we did lose track of time, yes, we were highly engaged, yes, we would love to see this in the classroom. And one of the side effects of it was our dean happened to be strolling around through here where they came at a time when all the tables that we had were full, and we co-opted all the tables from the local cafe as well. And they said we want to run this across not just engineering, which is where I'm from, but across the whole faculty. For next year's Open Day. So we'll be, hopefully in 2020, you'll be escaping from La Trobe, or at least some of our students will be. Just a quick demo in the seconds I've got left. Very simple to use, we turn it on, and the thing I didn't mention before is it's got some sound effects, and I'm not sure how well it will go for the people at the back, but we've got the for negative sound effect, and the if you get it right. So thanks very much. Happy to answer any questions you may have on escape rooms or escape rooms in education and things like that more generally. Thanks again.
Thanks for the interesting talk. I think gamification is really important for education. One question I have, do you think how important is the hardware decoder? I mean, you could do the same thing with the web browser interface where it's also a big counting now.
Yeah. That's actually the question I get asked every time I give this talk, so I probably should include it in here. But we've run focus groups both with staff and with students, and we've asked a question related to this, and they've said, we like something physical. we like a piece of hardware we can interact with and do something with. I guess the other thing is an equity thing of if we get students to bring their own device and things like that, their phone might go flat, or there's things like that around there, but they've said we actually like the physical thing, not a web-based thing, which actually surprised us.
So one of the biggest problems with our group projects, and as a student I really hate this myself, is that 4 out of 5 members of the group eventually lose focus. So how do you maintain group focus when they're all doing this group activity?
Yeah. So with those group projects, this was another question that we asked our students. Most of our group projects would go for 6 to 9 months or something like that. So a very large project. And you have students that go off overseas and students that never respond to an email and they're like, who is this phantom student? We think they exist. With this, the activities vary up to about 45 minutes in length. That's about as far as we've pushed it. The interesting observation that we've made is in all except one, and in that case it was an academic, they've been highly engaged and basically hunched over the thing the whole time, trying to help each other solve it. So it's actually been something that we haven't had to really do. It was just this one academic was so far out of his comfort zone and so far out of it, out of the field. Having said that, we followed it up with that academic and we gave him an escape room that was the same one from Open Day, and he smashed it out and said, I want these in all my classes now. How do we do this? How do we do a virtual reality as well? So it was a bad initial experience for him, but then a very, very positive one afterwards.
More?
Oh, sorry, you can. Okay.
One and then okay.
So I was just wondering, like, how much of it do you think might be a novelty-based thing, and do you expect that it will be useful throughout an entire semester, or is it something that you'll use a couple of times?
Yeah. At the moment, we use it, so in my class, digital electronics and microcontrollers, we use it twice in the semester. The student feedback unanimously said, can you please have more of these? I kind of feel that every week might be a bit much, maybe every second or third week, so maybe you'd have 4 of them throughout a semester. It seems that there is a high novelty factor to it though. I guess depending on how hard you set them, the students might be a bit crushed.
One last question.
So you mentioned that a session can last up to 45 minutes, and that probably means that there's multiple puzzles for the students to solve. And what I see here is just a box with one solution, and then it probably opens or something. Would you explain how do you make multi-stage, multi-envelope puzzles using this?
It doesn't actually open. So when you turn it on, it says escape chute on there. If you put in the right, so it tells you at the start you're in round 1. If you put in the right code, let's get the right code. It will say you're in round 2 now. Correct round 2, and that will get you to open the second envelope, and then you'll be validating against a different answer. Having said that, the timing is completely up to you. It's programmable from 1 second up to 72 hours. Not that many of our students would have the stamina for that.
All right.
Yep.
All right. Thank you.